So let's just see how we can perform deletion in a BTree. So here we have given this BTree. So let's just see how we can delete key from this BTree of order 5. So because here the order m is 5, so that means the minimum children will be 3, maximum children will be 5, minimum number of key will be 2, and maximum number of key will be 4. Now except for the root node where we can have minimum key of 1 and the minimum number of child can be 2. So here we're going to cover all possible scenarios while trying to delete any particular key. So first of all, let's just delete the key 55. So we have to look for that key. 55 is less than 60, greater than 30. So here we have 55. Now here we have to check this node is one leaf node and it has 3 keys. So it has more than the minimum number of keys. So that means we can directly delete that particular key without any kind of problem. So this is the simplest way to delete any key. So let's now see how we can delete the key 83. So we have to look for that key. 83 is greater than 60. 83 is greater than 80, less than 90. So here we have this 83. So this node is one leaf node. This node has minimum number of keys. So that means we have to borrow from the left sibling. So here this is our node and this is the left sibling. So we have to borrow from this node. Now we cannot just directly borrow this from this node. We have to borrow through this parent node. So that means this 80 will come down. This 78, which is the maximum of this node, so this will go up and then we can delete that. So after the deletion, you can see we have still minimum number of keys. So that means we are maintaining the BTree property. So let's now delete the key 86. So 86 is greater than 60. 86 is greater than 78, less than 90. So here we have 86. So this node is one leaf node. This node has minimum number of keys. So that means we have to borrow. Either we can borrow from the left sibling, but because you can see the left sibling already has minimum number of keys, so that means we cannot borrow from this node. So that means we have to borrow from the right sibling. So this is our immediate right sibling. We can borrow from it because it has more than minimum number of keys. Now we cannot just directly borrow this. We have to borrow through this parent node. So because we are borrowing from the right sibling, so that means the minimum value will be brought up to the parent node, and then from the parent node this value 90 will be brought down, and after that we can delete that node 86. So after the deletion, you can see the BTree property still holds. So let's now see how we can delete the key 80. So 80 is greater than 60, 80 is greater than 78, less than 93. So here we have 80. So this node is one leaf node. This node has minimum number of keys. So that means either we can borrow from the left sibling, because the left sibling already has minimum number of keys, so we cannot borrow from the left sibling. So that means we have to borrow from the right sibling, but the right sibling also has minimum number of keys. So that means we are end up with this third option where we have to merge this either with the left sibling or the right sibling. So let's just merge this with this right sibling. So that means we have to merge these two nodes. So while merging these two nodes, also we have to merge this parent key. So after the merging, we're gonna have the keys 80, 90, then we're gonna have 93, then 97, and then 99. So after merging, we're gonna have these keys. But because we have to delete this 80, so we're gonna remove this 80. That means this node will be on the right side of this node 78. So let's now see how we can delete the key 30. So 30 is less than 60. So here we have 30. So here this is one internal node. To delete the internal node, either we can replace this with the in order predecessor or the in order successor, or we can merge them. So first of all, let's just see how we can replace this with the in order predecessor. So for this key, the in order predecessor means largest key on the left subtree. So this is the in order predecessor. So that means we can delete the 30 and it will be replaced with this key 23. So let's now delete the key 23. 23 is less than 60, so here we have 23. Now this node is one internal node, so that means we can replace this with the in order predecessor. So because this node has minimum number of keys, so we cannot perform this. So we have to use the in order successor. In order successor means minimum value on the right subtree. So here 45 is the minimum value. So this is the in order successor. So that means we can delete 23 and we can replace this with this in order successor. So let's now talk about this third case. So suppose you are trying to delete the key 45. So 45 is less than 60. So here we have 45. So this is one internal node. So that means we can replace this either with the in order predecessor, but because it has already minimum number of keys, so that means we can replace this with the in order successor, but also that node also has minimum number of keys. So we are end with this third option. We can merge these two nodes. So that means we can merge this left and right child along with this parent node. So if we merge them, so we're gonna have 21, 22, then we're gonna have this 45, then we're gonna have 50 and 52. So this will be our merged node. Now from this we have to delete this 45. So we're gonna end up with these 4 keys. So that means this parent key will be deleted and we're gonna have the key 21, 22. So on the right side of 20 we're gonna have this node. Now we are not still done yet because here we have one single key. So in a B tree with order of 5 we cannot have one single key. We should have minimum of 2 keys. Now this node will try to borrow from this immediate sibling. But here also we have this minimum number of keys, so we cannot borrow from there. So now we have to merge them together. So we have to merge these 3. So that means this root node will come down at this level and merge with these 2. So if we merge these 3, so that means we're gonna have 20, then we're gonna have this 60, then this will be 70 and then 78. So this will be our merged node. So all of these will be deleted and we're gonna have this merged single node. Now on the left side of 20 we're gonna have this node. Now on the right side of 20 we're gonna have this node. Right side of 60 we're gonna have this node, and on the right side of 70 we're gonna have this node, and right side of 78 we're gonna have this node. So this is called the shrinking of height, where the height of the B tree is shrunk after the deletion. We have covered all of the different scenarios that can occur while trying to delete one particular node in a B tree. So hope you understand about the complete deletion process. See you in the next one. Take care.